That brings us to the mean value theorem. And the mean value theorem has a similar hypothesis to Rolle's, except that the endpoints are not, the function's not equal at the endpoints anymore. So we have the same continuity and the same differentiability hypotheses. So the mean value theorem tells us that there's a number c in this interval such that the derivative evaluated at that number is equal to the average rate of change of the function between the endpoints. And remember, this is the slope of the secant. So the mean value theorem guarantees there's a point on the graph where the tangent is parallel to the secant, right? Because remember, the derivative is the slope of the tangent line, and when two lines have the same slope, they're parallel. So you can move this point to look at the tangent line as you move along this curve, and you can see in this example that there are two values of c where the tangent line is going to be parallel to the secant line that connects the endpoints. So in this case, the mean value theorem gives us two values of c. Verify that this function satisfies the mean value theorem on this interval. Well, we know the natural log of x is continuous on its domain, which is 0 to infinity. So it's going to be continuous and it's also differentiable there, so it's going to be continuous on this interval 1, 4. It does satisfy the hypothesis, so we know that there's a number in 1, 4 such that the derivative of ln of x evaluated at that number is equal to the ARC of the ln of x, which is the slope of the secant, that interval. And then when I find the derivative of ln of x, I get 1 over x. So I know that to find c, I need to set my derivative equal to ln of 4 over 3. So to solve 1 over x equals ln of 4 over 3, I get 3. X is equal to 3 over the ln of 4, which is approximately 2.164. So what that means is the slope of the tangent line is the same as the slope of the secant line at the x value 2.164. Next example, find the number c that satisfies the conclusion of the mean value theorem for this function, then graph it. So again, we take the derivative. We first note that the function is differentiable on 0, 4 and continuous on the closed interval. So we find the derivative, which is 1 over 2 times the square root of x. Then we find the slope of the secant on that interval, and that gives us 1/2. So we set the slope of the secant equal to the derivative evaluated at c, and then to solve for c, we just solve this equation. So c equals 1.